Sorry. Good afternoon. Sorry about that. And I apologize also in advance that you have to listen to someone speak English right after lunch, but I hope that the topic will be interesting enough to keep you engaged. My name is Alva. I'm from the Dutch Marine Energy Center, but don't be scared about the name. We don't only work in the Netherlands, but we also work internationally, so a lot in Europe and also globally. And I want to introduce you to multi-source offshore renewable energy parks. And I want to start by saying there is another really interesting resource in Chile, which is wave energy. And you can see here with a little square that in Chile, actually, the wave energy potential is very high. And if you are interested in more specific details about that, you can also look more into that in this link that I will share, or that is on the slide. And why I'm here at the OffshoreWind seminar talking about wave energy is because with all this interest arising now in large-scale installations up for floating or also offshore wind in Chile, the question arises, or the opportunity arises, of multi-source parks. And this is, for example, a multi-source park, which includes different resources in the same area. So co-location of different resources. You can see here, for example, the co-location of wind and wave on the left side, but also wind and solar on the right side. And I think Chile would be a really interesting region for these opportunities. And why I think it is also interesting, I want to share with you today. There's two main characteristics of multi-source parks that improve or give advantages to this sector. One is the diversification of resource. The other one is the co-location. And I think the characteristics that I will talk about will also link nicely to things that have been said already in the seminar today. So I hope you agree or you find this interesting as well. So first, going into the diversification, you can see that from the power production side, so the figure in the middle, you can actually see the different resources producing electricity at different times. And this is good for a reliable and low-cost energy system. And you can see here also the less correlated the different resources are, the better this is for a more stable output. And we also saw that in Chile, the wave energy is actually also very constant, has a constant profile, both hourly and also throughout the year. So this is a quite nice resource that can be exploited at the moment as well. And what this brings is both on a technical scale or on a technical side, grid balancing. So the more constant output will help, especially also thinking about future electricity grids and the growing demand in electricity, but also the fast scaling up of renewable energy installation. It is quite nice to think about resources that produce energy or electricity in different times. And on the financial side, you can see that it increases your revenues, both because there is a continuous electricity sale, but also because it might be that when the prices are high because other renewable energies don't offer any electricity available, the other ones will. So the prices might be higher, and that can also increase your revenue stream. An additional advantage also from the diversification of the production is on the supply chain side. And I'm not sure if you can see, oh, sorry about that. Is a non-competing supply chain. So what you can see here, for example, for wind and wave, on the top you see how wave devices are installed with smaller vessels. And on the bottom, you see how offshore wind is installed. So this means it could lead to faster installation of large power capacities. So the installation capacity can be built up more quickly. And also there's no bottlenecks caused by developing both technologies. And these pictures now show the installation, or this also is is valid for the manufacturing process, for example, as well. So it is quite interesting from the supply chain aspect as well. Then going into the other reasoning, the co-location, it is quite interesting because the different resources, so the different technologies can share the same area, but not only the marine space, but also the electrical infrastructure. So the substations, the cables, and also the vessels for example, operation and maintenance operations and activities. So this will lead to a cost and space efficient utilization of the offshore area. And on one side, we'll be able space reduction, so more installed capacity for the same area, which is both good for the infrastructure, but also for nature, if you want to consider that, if you need to consider that as well. And then in addition to that, it also decreases the costs for the entire system because you are installing more capacity by using the same infrastructure. And some other aspects that could be considered here are that the substation and this electrical infrastructure usually has really long lead times. So it's good to use it as much as possible so that it might be necessary to install less of them, or it might, because it might take longer, it is exploited as much as possible. So if we consider these multi-source parks and in general also the upscaling of offshore energy, we're talking about innovative solutions, and they're at the moment early stage projects. So I also want to talk to you about what DMEC does and how we help bridge the gap between this innovation and the project developments. From DMEC's perspective, we work in close contact with many stakeholders of the energy transition. So we work with technology developers, project developers, but also policymakers. And we have a large network with whom we work. And our goal is to accelerate the offshore renewable energy sector. And internally, we have some models that we use to study the offshore renewable energies. So here we have 3 different models that we use internally that we can apply. So one is the multi-OR that I will focus on today as well, because it is assessing multi-source parks by studying their power output and also calculating the techno-financial performance of them. We also have the growth model, which focuses on the market potential and growth opportunities of emerging technologies. And we also have the LCA model, which looks more into the sustainability and environmental impacts through life cycle assessment. So if we look into, for example, an example of the multi-OR, what we do is basically we create, so this is an example of the North Sea, and you can see this is just one of the initial steps to creating the techno-financial analysis. We create these power profiles based on the installed capacity. Here you can see wind, wave, and solar. The wave resource in the North Sea is is very correlated with wind. So actually we decreased the installation capacity in this case, but this is just to explain more or less what our assessment is based on. And then we do a technical analysis. So we try to, for example, optimize the power systems by looking into the annual energy production, the curtailed energy, and also, for example, the export cable capacity. So using as much as possible of the electrical infrastructure, as mentioned before. And with that, then we also make financial assessments. So we look both into the revenues, as potential revenues as well through, for example, PPAs or CFDs. And then we calculate the financial metrics like the levelized cost of electricity and the net present value. And this is, again, just an example of the North Sea, but we're looking forward to any opportunity in which we can use our models and showcase our approach also in potential cases in Chile, for example. We also do sensitivity analysis with this model, for example. And as I am already a little bit over time, I just want to close off with 3 key messages that I want you to consider. And hopefully it was also a bit the red thread of the presentation. So on one side, it's important to look into also the future electricity grid and what the problems might be in future, especially looking into the increased demand of electricity and also the increase or scale up of renewable energies. And we think that multi-source parks can help the future electricity grid. And there are technical and financial advantages by co-location and diversification of resource. And the other step that also fits a bit into what was discussed as well, the regulatory frameworks that will be created now for the offshore environment should also consider these future options. So it is to have a more overarching consenting process, which also includes developers of the other technologies, is very useful for the future electricity grid. And that's it from my side. Thank you very much for your attention. And if you have any questions, you can always ask or also contact us.
So maybe a question from online. So Alva, here we have a question from the online audience. So, gracias. So basically we wanted to ask, what other conclusions have you extracted from the analysis, if it's possible to say, of course, from the EU scores in Chile? Is there any other conclusions or any other heads up?
Thank you for the question. So in the EU Scores project, and you might have seen in the slides always the logo, we are looking into Chile. For now, we are still quite at the beginning of the assessment, but what we saw and what I also mentioned in the first slide is the global wave energy potential, and it is very strong in Chile. So we will be looking further into locations and understanding how it can be included in the overall targets.
And one more question. Why did you choose Chile?
Because of the first slide, and because thanks to the help with MERIC, we have a really nice connection to Chile and understanding the situation there.